So yeah, I'm going to tell you the story about Dimension Data and how we're involved with the Tour de France and the solution that we have that helps support that. I've got a pretty interesting job. I've been working in sports in Dimension Data. This is my 5th year doing it. And my official job title is Director of Architecture, but I've been described as many different things. One of them, Supersport, one of the film producers in this country, they actually called me and one of my colleagues cycling data nerds, and I was quite happy with that. So, but me and the rest of the team, we basically get to go and work at the Tour de France every year. We do an extortionate amount of traveling. Basically that means we're at the Tour in July for the whole month, and we go and do a sort of test run in June at another race, the Criterion de Dauphiné, where we're out again for another 2 weeks. So yeah, with my wife watching, it's obviously tough for the family, but a really rewarding job. So I'm going to tell you a little bit about that. So we started our journey with the ASO in 2015, and they kind of came to us in January of 2015 with the brief of the following. They kind of wanted to get to know their clients a bit more, but traditionally, the ASO, they are a media house, basically. So they've started their journey selling newspapers. So they've then, over the years, evolved and bought sporting events to help sort of make that better. So they're quite a traditional organization, 105 years old, owned by a very rich family in France called the Amaury family, surprisingly. And they do various different events. One of those events that I would really, really like to be a part of is the desert race that they have going on every year, which is really cool. But let's just dig in a little bit. So they started the Tour de France 105 years ago. Now, can anybody guess why they started the Tour de France? Exactly. So they wanted to create stories. So they wanted a medium to create and invent exciting stories to sell more newspapers. So that was their primary driver through this. And obviously then they've evolved as a business, and the audience has evolved as well. So how people consume that information, it's moved from newspapers, and then over a long period of time when radios come about and more people have got radio, they've then moved to that medium. And then TV. So when they came to us in 2015, their goals were kind of 3 different things. They wanted to basically extend the reach of the fans that they had, because, I was quite interested there to hear that, some people actually do watch the whole Tour de France. Is anybody else who can spend 21 days watching the Tour de France? So if you'd like to give me a business card after, I want to come and work for your company. Because no, I mean, it's, 5 hours racing over 21 days. It's a lot of time to be, spending watching TV. So they wanted to create a new medium to engage new people, so the rest of the room, basically, in a digital way. They also wanted to break out into some other markets, like over in the US and in Asia. And they wanted to sort of attract a different demographic of people as well. So, at the Tour de France, you go and watch the people at the side of the road. There's young families, but there's a lot of old people. And it's traditionally, that's what that's the people that go and watch it. That's the people that can sit there, have got the free time to watch it on TV. So we wanted to help them drive all that. So, from our perspective, it was a challenge. How do we sort of leverage? How do we use technology as a question to answer the challenges that they had? And if you think about the tour in itself, I quite like this conference because it's ScaleConf. And in my mind, the challenge that we had was twofold. It was, how do we get the scale on the front end digitally so people could come and see? We had enough sort of scale to be able to service all the people around the world. But also, how do we create a solution that scales hundreds of kilometers? A technical solution that enables us to get data from one place to another place in very different sort of terrain. So this is this year's Tour de France, right? And you can see it starts in a different country. I mean, so we're not even talking about the same country, geographical location. But we then go through the northeast of France. And then as we come down into the Alps and the Pyrenees, obviously we've got 3 very distinct sets of terrain there. We've got cities, big major cities where there's infrastructure. We've got the rural countryside. And then we've got the mountains. Now, how do we create, how do we enable us to capture data from a rider, for example, in the city, it's quite easy. You could just use telecommunications. In the rural countryside, well, there's no 2G or 3G in quite a lot of rural France, and I can tell you that from sitting in the back of a van being driven around for hours on end with nothing to do. And once you get up to the mountains, which is, of course, where all the interesting action happens, you know, you've got 20,000 people there. If there is a mobile network, it's completely smashed out by everybody trying to go onto social media and send information and you know, do what they do normally. So if we look at this, we've got a kind of stage profile. You can see, you know, it starts out pretty flat, this one, and then there's 4 distinct large climbs here. So you've then got to deal with, well, not just that one mountainous region in this particular stage, but 3 or 4 of them. So how do you then create something that enables and allows you to capture that information and then push that out to the general public? So let me tell you a little bit about the beginning of the story. And I laugh because I look at some of these things, like some of these pictures. So this one on the top left-hand side is basically the wiring diagram of the technical zone at the Tour de France. Now, if you can imagine, you have hundreds of trucks there that build up every day. So 21 days, you rock up, you're with your truck. The first problem that you have is, okay, where's my truck? Because there's hundreds of trucks there. So once you find your truck, you need to then find the people that you're integrating into. And there's this just rat's nest of wires everywhere. And you become part of that wiring issue. You basically put down more, you go and plug into the different trucks that you're there. And when you go to the truck, you're presented with things like this, you know, where it's not really very enterprise and, you know, cables are hanging out and it's like, oh, it's not really the best. So one of the problems that this actually produces and has happened to us is that people come and they'll kick your cable out. So you would not believe I've had to learn the intricacies of unwinding cable to make sure it stays flat, which I never thought I'd have to do. So yeah, you get people walking past, people are always messing about, other people are plugging into this stuff, so you've got to be prepared you've got to be prepared for things that you would never plan to happen, like cables getting kicked out. And unfortunately, you can't really go and stick multiple cables in there because they don't have the infrastructure that supports that, so you end up having problems. You've just got to be very alert to what's going on and making sure that you're monitoring everything that's going on. So if something does happen, you can react very quickly and rectify the situation. The other thing that I'll say is, you know, there's nothing quite like the office view from being in the mobile office where we get stuck outside the toilets, basically, which is, it's not the best sometimes. And again, that can be a problem because that means there's more footfall traffic. Also, weather conditions, you know, it could be, we've had it, I think in year 1, we had it where it was 40 degrees in the truck. I mean, we had a small data center in there, which I'll talk a little bit about in a moment. And we had sufficient cooling, but we didn't have sufficient cooling for the people that were working in the truck. So it's 40 degrees, we had a black truck, no windows, and it was like a sweat box. So I think we all came back about 3 or 4 kilos lighter than when we left, even living on a diet of baguettes for the whole period. So, so basically what we've done is we have a truck as part of our solution. And again, another challenge that we have is, you know, we don't own the truck. We lease a truck for 2.5 months a year. And when we finish that at the end of July, all the stuff, all the solution that we've built up actually gets packed up into boxes and looks like that. So that's our solution at the moment for the Tour de France. It's sitting in Holland in a warehouse, and in a couple of weeks' time, it'll start getting put back into the truck, and we'll start testing and doing any updates and upgrades we wanted to do for that particular physical part of the solution. So yeah, an interesting challenge. I suppose we've learned over the last 4 years that you have to be adaptable and reactive and quite flexible as well in multiple ways, both in the physical infrastructure that you've got there, but also in the way that you integrate with the partners that are on site, because things amazingly change all the time. I was laughing earlier about, you know, one of the presentations where we were talking about testing in production. Well, we test in production, but live on TV, which is quite nerve-wracking and taking it to a whole new level, I can tell you. So what did we actually do? I mean, I've talked about it. I talked about, you know, the intro and the challenges around it. So we kind of put together this. I love this diagram. This makes something very complicated look very, very simple. In essence, and we'll go into this in a bit more detail, what we're doing is we're taking GPS location information from each cyclist, and we're then transmitting that via a helicopter or a plane to a truck that we have at the end of the race. Now, in 2015, we actually had a data center in that truck. So we went and we kitted out a data center. We had a load of servers in there. They're running our analytics platform. That in itself brought quite a few challenges because having to reseat DIMMs every day after they've been rattled out from driving 300 or 400 kilometers is not something that I enjoyed, I can tell you. So we ended up evolving that platform in the big data truck, and it's actually the second year, we had fun. The second year we evolved it into and used a hyper-converged system. But that was great until somebody pulled the power on us at the end of the race without shutting everything down, and it took 4 hours for a SAN to rebuild. And that came up 5 minutes before the race started, so we were okay, plenty of time. So we eventually got to a point where it was like, this really doesn't work, having this data center in the back of a truck. So what we did is we were actually forced into the position where we had to use a cloud service. Now, the ASO are a traditional company. Everybody's always delivered services at the end of the race, so this was kind of a new thing for them. But there was actually a stage in 2016 at an iconic climb, Mount Ventoux, which I haven't ridden yet, but hopefully will this year. And the winds at the top of Mount Ventoux were 130 kilometers an hour. So we got an SMS from the ASO probably about midnight, 1:45 in the morning saying, the technical zones, so where all the trucks are is a technical zone, and this, because of the nature of Mount Ventoux, had two, so it split, and Orange had come and put fiber between the two, so there was connectivity. They said, because of the winds, we've had to move the technical zones down, so the top technical zone was halfway down the mountain, and then the bottom one was in a village miles away with no connectivity, and we were in the bottom technical zone. It's like, well, hang on a sec. That's where our stuff's running, and we've got no connectivity now, so we can't actually do anything with the truck. So our worst fear of the truck being taken out is what happened. So we did have a backup plan, and we ran everything in a cloud location in Amsterdam, and we delivered the service as we expected and as we'd said to the ASO. But what that enabled us to do was it was a catalyst then for us to be able to run more and more services cloud-based from the following year. So now, the big data truck is more a connectivity and collaboration hub. So we have people from Dimension Data in there. We have the ASO in there. We have partners in there. There's services that we deliver at the end of the event. So, for example, we plug directly into the TV broadcasters, so that data flows really quick. We have the commentators sit there, and there's a commentator's application that's delivered locally. Now, the end of the race is a funny place. So we actually did a commentator's application a few years ago, or the first version of it that we did, and we decided to deliver it with Wi-Fi. So it was not the best experience because the other 350 other Wi-Fi networks were there. It was quite a noisy environment. So now we actually have a team that wires that in, and it's a bit of a better experience for everybody. So yeah, and then during the Tour de France as well, we kind of have our clients coming through. So we have a customer experience center, and this year they're lucky enough. So there's another part of the team that deal with social media, and they're actually going to be sitting in this other truck. So now we have brought another truck into the equation as part of the solution. So those guys will get there. We've put them in a little glass box so everybody can look and point at them. We're calling it affectionately the goldfish bowl. I don't envy those guys, but. So yeah, and then so what we do is we analyze that data in the cloud, and then we've created a platform called Race Center. And Race Center is an amalgamation of different rich content, rich media content, input from journalists, the data from live tracking, and the analytics that the outputs from the algorithms that we've created. And it basically gives a really good second screen view of what's going on at the race. Or if you can't watch TV, it's a great way to just consume what's actually happening in there. So yeah, that's basically, in essence, what we deliver. How do we do that? And I will go into the technical a bit more in a second. How do we do that? Well, so Dimension Data's in 53 different countries. And we actually tried to use that to our advantage right at the very beginning. So I think one of the tightest timeframes or deadlines I've ever had in my life with 100% unmovable deadline was the Tour de France in 2015. We signed an agreement with the ASO in January, and we agreed a statement of work in March, and the race was in July, which was kind of stressful. There was a lot going on because we basically had to build everything from scratch. So we chose a team that were distributed around the world. And myself and another chap called Peter, who sits in Melbourne, I remember my family being away for the month, and we were literally tag teaming every 15 hours just to get as much as we could possibly do done in a month, which was well hectic. So I remember that we did the test race in June, and the truck was still being built like 3 days before, and the infrastructure going in. So it was really tight. But we did it. We got there. And we used the people, around the world to help us do that. So now, one of the reasons I'm here in South Africa is because we've got quite a lot of offices here, and Dimension Data is obviously a South African company originally, but we use the developers in Johannesburg as part of this team. So we have a core dev team that's there. But we've also got other guys in the UK and in Australia as well that help as part of this solution. So during the tour, it's pretty hectic. If there are bugs that pop up, because you can only test so much when it's not in production. We basically have people developing overnight, and then we can test and then roll back out the following morning, again, live on TV. So this is where it all started, and that's actually the first GPS record that we got through on the first tracking of the live race, and that's in Utrecht in the Netherlands. It's quite an interesting thing for me to see, because we'd worked so hard to get to that point, and so much time had gone in. It's pretty cool just to see it all come to fruition. But I think the interesting thing is what we then started to do with that, and I'll go into that in a minute. So how did we do this? The telemetry data, so the data coming off the bikes is quite a complex solution in itself. We're actually using a sort of mesh network for the riders, and they can either bounce off gateways that are part of that mesh network. So we've basically got a piece of licensed spectrum in the 900 frequency, something 900 megahertz frequency range, and we basically push data out of those, every second. They can then bounce off a motorbike or go directly to a helicopter if it's in range. Now, the range of those is roughly about 10 kilometers we can get out of them line of sight. So usually they'll take the most direct path, but sometimes they can't, so they'll bounce off a motorbike. Once they eventually get to the aeroplane, we're actually piggybacking up on the TV transmission. So they have 5 motorcycles that ride around the race, and also the helicopter and plane that's in the sky, and they're all sending their video content back to the end of the race. Well, we piggyback in that, and they've got 3 microwave links that go to the end of the race. There's a huge cherry picker that's like higher than anything else, and they're basically sending the data back to that. Once we get it at the end of the race, we basically demultiplex out of the data back out of that transmission, and then it's ours to start playing around with. If we look at that from, I know this is pretty high level, this one. If we look at that from an end-to-end point of view, let me talk you through each step and how it's connected. So we just talked about the bicycle and the helicopter, talked about the transmission to the end of the race. But we do a little bit of edge processing at the end of the race. We actually combine all the records. So there's 192 riders, and we basically combine all that information into one JSON, and we correlate that through from the timestamp that we've got for it. We then do a few different things. We send that directly, so that raw data gets sent directly to broadcast, right? So it actually takes 2 seconds for the data to come from the bicycle to the end of the race. Now, if we want to keep in synchronization with the TV, we've got 5 seconds maximum to do our analysis on that with. So when we very first started, working with the ASO, we actually made that decision to have that raw data go straight to the TV, because then we're always going to be in sync. I won't lie, the first year we had a bit of tuning on the analytics platform, so we were probably outside of 2 or 3 seconds to analyze the data. Over the last 2 or 3 years, we've actually got that down to half a second, so 500 milliseconds to do our analysis. So we've now brought into the mix that we are able to take the data to the end of the race, send it to the cloud service, send it back, and it's still within that 5 seconds. So that information goes to the TV. We actually have connectivity by Orange. Orange come up and literally every day rock up with a fiber. So here's your fiber, and we have 50 meg synchronous connectivity, which is really good. It's better than my house, I think. So it's kind of, you go and do lots of downloading there. No, you don't really. But, so then we have another data path, which is to the commentators. And as I mentioned before, there's an application there that we've worked with the ASO, we've worked with the commentators to find out what is interesting for them, to help them tell the story. at the end of the race, there's something called the Tribune, and for those of you who've watched it, it's the big yellow trucks that are at the finish line. Basically, that's a sweaty hellhole full of reporters just sitting there watching what's going on and telling everybody around the world on radio or on TV, what's happening in the race. So we basically integrated into that and to other trucks that are at the end of the race. The main flow then goes up to our cloud location in Amsterdam, where we're running the analytics platform, and also the web platform as well, and an API service. And then we basically are using Akamai to distribute that around the world. And we get pretty much about 98% offload there, so it helps us do that big scale that we need. The only thing that really changes for us is the data. It's not the images. There'll be an image put up there, maybe 4 or 5 times, or a video put up there 4 or 5 times during the race onto Race Center, but the data is constantly changing, so caching all that stuff makes it way easier for us to manage. So I'll tell you a little bit about the data sources and how we analyze that, because there's not just the tracking information that we've got. And sorry, at the back, this might be a little bit small, and the color's not very good, I wouldn't imagine, for you to see. But if you're looking at this left to right, so some of the data sources that we have, we've obviously got the telemetry data, but what we actually did on the second year is we started taking environmental data as well. So understanding what's going on, understanding the grouping, for example, in the race, that's interesting stuff. But understanding, if there's 3 riders having a battle up a mountain, when you look at it on the broadcast, on the TV screen, it's very two-dimensional. You can see they're going up a hill, but you don't know how fast they're going. You don't know how big that gradient is or what the gaps are between them. But having all of that information together is sort of opens up the story and gives it another dimension. So yeah, we basically have telemetry data. We have information about the gradient because they share the stage profile with us beforehand. We have weather information, so we can see how that's affecting people. We have rich media content as well, which is obviously not analyzed at the moment, but we have been playing around with that, actually. And timing information as well. So you've got all these different integrations on the site, and we can then use all that and results as well. And you can use all that information to then analyze and help tell the story. So one of the challenges that we have at any event, I mean, it's not so much at the tour now, but during the first couple of the years, we basically would get there, and it would be very difficult. You'd go and you'd work with the partners to create your integrations, and you'd say, okay, this is the JSON standard that we're going to adhere to. This is what it's going to look like. And then you'd get to the tour, and they'd change something, so all your integrations were broken. Or it would be, no, actually, we didn't want a WebSocket, we wanted a TCP socket. So we actually needed to be really adaptable, really flexible on the edges of how not only we consume data, but how we then pass that data back out. And I think that goes across the board for any sporting event. You could, I think every sporting event I've gone up to, we've had to do the integration like 2 days beforehand because it always seems really difficult to get that agreement in place before. So again, having to be really adaptable. So we've used a couple of different technologies on the edge to help us do that. We use Node-RED and Apache NiFi as well. And that helps us, it's really quick and easy just to then create some different connections or WebSockets or whatever we need there. We've then got a little bit of edge processing, for example, deduplication. Once we get, as I talked through the transmission network, we can get duplicate results. We don't want that. We want those duplicate results or those duplicate records removed when they're concatenated into that one JSON file. We also remove erroneous data. Interestingly enough, in year 1, we had a situation where the GPS coordinates had been flipped around, so latitude and longitude had been swapped, which actually meant that all the riders were in the sea just off the west coast of Africa. So, so not good. But yeah, so we use those things, and we also we then created custom adapters to help us consume that data in an easier way. And then we've then created our almost modular-based analytics capability that then enable us to do things like taking the GPS coordinates and calculating the speed from those, based on the difference. And then we push that data out, so that's all in memory because latency is a huge thing for us. And then we can push that out into various different ways. So, to TV broadcast, we push out over a WebSocket, for example. We've made an API that then feeds our database, feeds our website. We push the data into a database as well, so that when we get the option to replay stages afterwards if we want to test with live data, for example. So yeah, that's basically it. This one's a little bit technical. So I mean, if you think about this from how we process, and I will share these slides because I'm pretty sure nobody, not even me, can read that from here. So that you'll be able to look at this in more detail. But basically, if you think about the flow that we have to create something as simple as a group, we basically merge those records as we talked at the beginning. We might have to do interpolation because sometimes we don't get the record, we don't get the information from the rider. I'll give you an understanding of that. When we did the first year, we were getting 80% of the race through the solution. We moved to version 2. We changed the firmware that we got and the approach that we had a little bit. Last year, we got 99.5% data coverage for the whole of the Tour de France, which was pretty impressive. But I mean, that more coverage enables us to do better things with the data. But in the odd case that we don't get the data or it's erroneous, then we do some interpolation based on some rules that we've got. We can then start creating, understanding where people are in the race, so their position, what the gaps are. And once we have those gaps, we can then start to create groups, for example. And we've written algorithms that help us, understand the breakaway group, for example, or the peloton, and what those group compositions look like as well. So all this then, because if you were watching TV, it's very difficult to understand who's where and what's actually going on. But this opens that whole thing up and gives you that information that you wouldn't necessarily have had before. So 2 years ago, we started playing around with machine learning. One of the challenges of working with professional sports, as professional athletes, is that they don't want to give their information away. So they don't want to let other people know their power or their heart rate, for example. And the reason behind that is if our team, if Team Dimension Data, for example, were having Mark Cavendish riding up a mountain, which he wouldn't be doing because he doesn't do that very well, but if they had Cav doing a sprint and we were sharing that information, you'd be able to see when he was at his threshold, and that would give an unfair advantage to everybody else to say, well, you know what, he's at his threshold now, attack him, and then we'll take him out of the race, basically, because they'll break him. So what we wanted to do is we wanted to create a machine learning model that enabled us to have an idea of how hard the guys were working, how hard are they working. So we did a few different things. We went and we profiled, based on the UCI results for the last 5 years. So the UCI, the governing body of cycling, we created profiles for all the riders. We sort of profiled them on things like time trial, team time trial, individual time trial, can they climb, are they a sprinter, that sort of stuff, to get an understanding of where their strengths and weaknesses were. We also looked at the trends of their most recent performance. Are they winning? Have they been winning recently? Are they on an upward or a downward trajectory? This then enabled us to do things like the effort index. And a way, and again, probably a little bit small, we basically used those profiles and then used things like understanding some of the physics about it, basically. Wind resistance, are they going up a hill? Whereabouts are they in a group? To enable us to then create models that gave us an understanding of how much effort they were putting in. And we used real-life data, not from the Tour de France, we used real-life data then to compare that, and it was pretty accurate. So it's kind of, from my perspective, it's not something that we're sharing actively to everybody during the Tour de France, but it's stuff that's being used by the commentators, for example. But it's really fascinating to see. You can sit there and you can then watch that they're actually not putting any effort in at all today. And you can see some stages where they're doing nothing, and other stages where everybody is working so hard because they're properly racing. And it's an insight into something you would never notice before. Just on a little bit of a different thing, there was something quite fascinating that I found out through us doing all this stuff, and it was we'd actually got another solution that we were using, and we were tracking power and cadence and heart rate and positioning of Team Dimension Data over in the US. And it was the first time we'd done that, and we've got this live dashboard, and we're looking at it going, there's something wrong with this. This guy's cadence keeps stopping. There's something wrong with this data transmission. But it wasn't. They just weren't pedaling. So they're sort of sitting inside the peloton, and it's also almost propelling them along, and they're not having to do any work. So it almost gives an insight into what was going on there. So it's kind of fascinating. So I think we basically take this data, we analyze it, we've created algorithms for it over the past 4 years. But I think there was something in year one that resonated with us all. It was almost a bit of an inflection point. There was a crash, a really bad crash that took out half the riders. And one of Pete and the team was looking at this data through Tableau. And basically it was just a massive, it was a line graph, just a massive crashy mess. And one of the social media girls that was in the van with us, a girl named Nolani, she took a photo of it and she tweeted it. And this tweet generated more interaction in one tweet than Dimension Data had on social media for the whole year before. So it was kind of like, hang on a sec. So we're taking the ASO on this digital journey, and what is it that we're actually trying to achieve here? How it should be. We learned from that the goal should be helping tell stories, because having all this data is great, but unless you can visualize it in a way that people can consume and understand, then it's meaningless. I mean, how many people in here are cyclists? Just put your hand up. There's hardly any of you. So, and how many's racing the Argus this weekend? Oh, there's actually a few of you. Nice, good effort. So unless you're a cyclist, and if I say to you, I was riding, so I actually brought my bike with me and I went for a ride yesterday, and I was riding into a headwind and I was pushing nearly 300 watts for 30K. Most people don't really think, well, what's that? What does that actually mean? I was working hard and sweating and red, and it wasn't really nice. The way back was great because the wind was behind me. But people don't really get what that actually means. There's no way to quantify it in their minds. So it's like having these visual representations gives a lot of, it helps tell the story, articulate the story in a lot better way. So we've done quite a lot of work on this, but the way that we actually push a lot of this data out is a few different ways, right? So, and I'll tell you how, and then I'll show you some examples. So we basically, I talked about the analytics platform, so we basically share that information via an API, and then we have Race Center, which I talked about. We push that out through Akamai, which helps us then get that global scale. We feed all the information into that, so we have a content management system that allows the ASO to push their information into it. Basically, this is the place to go. So those of you who are going to watch the tour this year, I'm expecting you to be on Race Center. We'll be watching to see if South Africa grows this year now. So, but basically, this enables us to give a local experience to everybody, wherever they may be. But we also push that information out over social and TV. So the visualizations that we have are used across 3 different mediums. So what did we do this year, or last year even? So we did a couple of different things. Talked about the machine learning already. We basically created a load of animated visualizations to help people see what was going on. And we pushed that out to social media and also to the media, and then we did the website. What does that really mean? I'll tell you what it means. It means things like this. So this is Race Center. There's a few different views in here. Basically a live tracking map, for example. Then there's this, which tells you where they are on the stage. This is the main view. It also gives you all the information that the press has put in, the ASO, the rich media content that they've put into there. So it brings all that data together in an easy way to consume. Also gives you classifications, so you can see exactly what's going on at the race. And we played around with live classifications last year to the presenters so that they could see exactly where everybody was. And that was really useful for them because it's quite difficult to see what's going on the video, or on the TV video. So we basically went and created a whole hash of live visualizations that we would use, and these were getting embedded into Eurosport. We were pushing them out on Atlator Data, which was our social team that were doing this. But the TV broadcast was so interested in it, they wanted to embed that as well. These were just created in PowerPoint, but we're actually looking at using D3 this year, although that body of work's just starting. So we actually work on the Tour de France for pretty much the whole year. As soon as we finish one tour, we all go on holiday for a month, and then we basically start again for the next year. So it's like an ongoing thing that keeps on going and going. So some of the other stuff was, you know, the DD predictor. So one of the other machine learning models that we created using the profiles that I talked about, using the stage information, using the weather, we basically predicted the top 5 riders that were going to win. The ASO didn't want us to predict the winner. And to be fair, the first year that we did it, it would have been Chris Froome every stage because he just was winning. So not really so interesting, is it then? But yeah, so we created that. And then we did something interesting as well. We did a break catch predictor. So, you know, during a cycle race, there'll be a breakaway, which is a group of a few riders that try and escape the main peloton and see if they can win. They're basically trying their luck to see if they're just having a crack at it. And sometimes they get wound in and they'll catch them up, and other times they don't. So we wanted to figure out whether we could predict whether they were going to get caught or not. We actually did really well with this one. I think we were getting 80% accuracy on it on the first year, which was really decent. Machine learning and prediction in sports is inherently difficult because there's so many unpredictable factors like people falling off or, you know, farmers picketing. There was like 2 years ago, there was or the police tear gassing people. That happened, and a load of riders got tear gassed a year ago. So you can't kind of build a model to predict the unpredictability of sporting events like that, especially when they're all over. So yeah, all things considering, we actually did really well. The other thing that we did that was quite funny is our driver, a guy called Reen. So there's the team, we don't drive ourselves around France because we end up having to work 15 hours a day and then drive for 300 kilometers after a race was deemed to be a bit dangerous, especially after year 1 when I nearly crashed the car. So Reen's an ex-pro. He works with Team Dimension Data, and he's pretty clued up. So we pitted him against the team, against the machine learning model, and he didn't do very well. Reen got 2, and the machine got 7. He was quite upset about that, so he didn't want to do it the following year. So, but some of the other stuff that we put out, I mean, we did the profiling. We gave that information or those visualizations to the press and out on social media so that they could see, you know, how we profiled people as well, adding another dynamic to how people consumed and how people understood what was going on at the event. And that is everything. So I want to open up for questions. Thank you.
Okay, we'll take questions, and just to remember, a reminder, a question of the day. At the moment, we haven't found one that the judges have latched onto, so there's a lot of influence can be made in the last set of questions.
Yes. Not too difficult, though, eh?
So what about the tote, the betting houses? Do they have a problem with your stuff?
No, so we don't actually, the only people that get the information, the raw information, is the ASO, and then we provide a fire hose stream to the teams, and that's it, and us, basically. So everybody else is seeing that, I won't say filtered view, but the view that we want to present them to. If I look at other sporting events, like horse racing, for example, there's a lot of activity currently in doing things similar to this, and then using that to generate revenue from the totes and people.
Hello, thanks. So you mentioned that you were using machine learning with temporal data. Were
Yep.
you using like recurrent neural networks, or what method were you?
So we were using IBM Watson, and I'm not the expert in machine learning, and I actually knew that somebody would ask me about it.
How do you identify which sensors coming from which rider? So when bikes are being swapped and mechanicals and all of that, how do you actually map riders to sensors?
So each sensor has a 3-digit ID, and we have to, so one of the challenges is, of course, they crash their bike and the new bike won't have a sensor on it. Yeah, so you basically have to remove them from the race. But we work with the mechanics, and the mechanics will put them on, and then they communicate back to us that, you know, rider ID 216 is this one. So we get that communication from them every day. So we basically have an updated list, and it's part of our sort of startup procedure to make sure that we've got everybody. Because the other thing as well is that riders get removed from the race as well, so we have to make sure every day that we remove those guys.
So if you got approached by another bicycle race, say like the Absa Cape Epic, how much of your infrastructure could you recycle?
So we actually do stuff with the Absa Cape Epic, believe it or not. So yeah, it can. So we've done lots of different events. So we've done the Cape Epic. There's a local team here, and a guy, Wolf Stinnes, who leads most of that up. But interestingly, we've done stuff with Red Bull last year. So I was out in Utah, and we did the downhill event, which is called Rampage. And that was a definite developing and testing in production live on TV, because the first time we did an end-to-end, and by end-to-end I mean top to bottom of the mountain, was live on TV, which was quite nerve-wracking. So yeah, it translates really well. And some of it, not so much, because if you think about the whole race centerpiece, that's very tailored to what the ASO's requirements are. But things like how we operate, the operational model, for example, is transferable to anything. And we've got different technologies that we can use that don't require a helicopter or a plane to be in the air to track.
Thanks so much. I really appreciated that. I love following Race Center, and so just getting a bit of a sense of what goes on in the background is awesome to hear. DevOps engineers and developers are generally really good convincing their employers that they can work from home, work from anywhere. How many of your guys stuck in the office are trying to convince you that they have to be in France to do the job?
So that's about 28,000 of them. It's like the no. Look, I mean, our teams. We only have a core team in France because it's quite expensive and cumbersome. If we have more than 7 people, they basically don't fit in one van. So it means we have to have more people, more vans to ship everybody around. Plus, it's really difficult with hotels. You can imagine 20,000 people wanting to go and watch a stage at the top of a mountain, and there's 3 hotels there. It becomes a bit of a challenge there. So I think right at the very beginning, we were using quite a lot of different collaboration tools to help us work remotely. And with the team structure as it is, it kind of works well. We've sort of embedded that into the whole process. But they all would love to come.
It's a bit of an existential question about sport in general. As we progress and we know more and more about what our athletes are doing, both through direct telemetry, power meters. I know Christian Prudhomme doesn't like that and they want to ban them. But Tour de Suisse is doing them. Other people are going to do more and more. You've got your machine learning models. How much of that starts to feed into our athletes performing as they should? So we can test doping. We can do that at the front end. The data you've got is really, really useful for that kind of back-end testing of saying, this guy didn't perform as he should have. How did he do this? And I don't know, maybe your opinion on that and what it means for the future of sport as we know more and more about what athletes are actually doing.
So I actually think there's a couple of different aspects here around performance. So we obviously, we're obviously title sponsors of a cycling team, so we can see what happens with those guys. And they're all using things like training peaks, for example, to gather that data from things like power meters and heart rate to understand what's going on. But one of the other things that we've been trying to help them with, we've been trying to help them with a couple of different things, is more around their mental well-being. So, are these guys mentally fit to be racing? Are they at their prime? Do they feel ill? What have they been eating? How much do they weigh? So starting to get all that other information and then using that combined with what's going on in training peaks becomes quite a powerful tool to really, use the guys to the best ability. So one of the other things that we've done as well is that we've created some analysis around, which like races will give the most points. So for example, I think it was the Tour of Turkey, you can get a load of points, but nobody goes there, because why would they? So, good. I didn't mean that in a bad way. So, can we delete that from the video? So, but it's like, so if you can earn so many points going to that, then it's a strategical decision. If you understand, your fitness and mental fitness of your guys, and then you understand that, traditionally this race has only, sort of had the B class category sort of riders in there, you're like, it's a no-brainer. You send the guys there, you're going to get the most points. So yeah, there's a few different elements of that. I think that's all coming together for at least team dimension data. So.
Can I ask? Hey, so So my question is, has anybody requested from your data sort of where the riders have been doping or anything? So like one algorithm that comes to mind is Armstrong's algorithm of artificial performance.
So at this time at the moment, I don't believe that either CARDA or the UCI are using telemetry data to understand if people are doping or not. I think it's quite a controversial question, but I do believe myself that in the next 2 to 5 years that there'll be a standardization of that technology, and then it will be used. And once you start getting the data sets in there, you'll be able to correlate that to see if people's performance is unnaturally increasing, for example. So yeah, at the moment, no, but in the future, yeah.
Yeah, I'd just love some stats on number of endpoints, how many servers, how much MIPS, how many transactions a day.
So we usually get about, on the web platform, we've got about 120,000 concurrent users, which they're obviously pushing through quite a lot of requests. But like I said, we got 90% offload. We only, and what that equates to, so we basically have almost a two-tier. We've got a web layer and an API layer, and that web layer calls back to the API layer for the data. We only have 6 servers on the web layer, and we only have 4 servers on the API layer. So it's really small because we get that huge amount of offload.
Being in the front lines and collecting data around this, I'm curious to find out if you or your team has had any thoughts on when or if anyone is using some of that data to try to put together autonomous agents, and when you think that might happen, to kind of design autonomous agents or robots or something of that nature that would be able to operate in sports and compete with humans. Do you see that in the horizon anywhere?
So we've been using robot process automation last year to interrogate that data, but I don't know if anybody else has been doing anything around it.
I thought that question was, are we going to have robots doing the Tour de France or something for a moment?
Do you know, I actually think that there's some interesting technologies that are coming through, and I fully believe that one day we'll have robot commentators.
They probably talk more sense than some of them.
Yeah, hi there. So on your data processing architecture diagram, you kind of had Mongo over there. Do you have any issues with like scaling that or problems? Or?
Yeah, we definitely don't have Mongo with people querying that all the time. We're just storing the raw data into Mongo.
Oh, okay.
So yeah, in other events, we've had huge issues with scaling Mongo. So we tend to stay away from it for anything front end.
So thanks a lot, awesome session. In the middle. I'm a huge fan of cycling, and my manager is not here. So do you guys have any open positions on your team?
Sorry, what was the question?
He wants a job, basically. Which that does exclude you from it's streaming on live. So your manager might not be here, but you're still fired. Oh, okay. Cool. I think we'll call it there. So let's thank Tim.
Thank you.